Hello there, welcome back. In this lecture, we'll go over the payback period. The payback period is the time required for the amount invested in a project to be repaid by the net cash inflow generated by the asset. It is a simple way to evaluate the risk associated with a proposed project. The payback period is expressed in years and fractions of years. For example, if a company invests $300,000 in a new production line, and the production line then produces cash flow of $100,000 per year, then the payback period is 3 years. 300 initial investment divided by 100,000 annual payback. An investment with a shorter payback period is considered to be better, since the investor's initial outlay is at risk for a shorter period of time. The calculation used to derive the payback period is called Payback Method. The formula for the Payback Method is simplistic. Divide the cash outlay, which is assumed to occur entirely at the beginning of the project, by the amount of the net cash flow generated by the project per year, which is assumed to be the same every year. Let's say we have an organization that is considering the purchase of a bandsaw that costs $50,000 and which generates $10,000 per year of net cash flow. The payback period for this capital investment is 5.0 years. This organization is also considering the purchase of a conveyor system for $36,000, which will reduce the sawmill transport cost by $12,000 per year. The payback period for this capital investment is 3 years. If the organization have only sufficient funds to invest in one of these projects, and if it were only using the payback method as a basis for the investment decision, it would buy the conveyor system, since it has shorter payback period. The payback period is useful from a risk analysis perspective, since it gives a quick picture of the amount of time that the initial investment will be at risk. If you were to analyze a prospective investment using the payback period, you would tend to accept those investments having rapid payback periods and reject those having longer ones. It tends to be more useful in industries where investment becomes obsolete very quickly, and where full return of the initial investment is therefore a serious concern. If an asset's useful life expires immediately after it pays back the initial investment, then there is no opportunity to generate additional cash flow. The payback method does not incorporate any assumption regarding the asset lifespan. The concept doesn't consider the presence of any additional cash flow that may arise from an investment in the period after full payback has been achieved. This method doesn't take into account the time value of money, where cash generated in later periods is worth less than cash earned in the current period. Incorrect averaging. The denominator of the calculation is based on the average cash flow from the project over several years, but if the forecasted cash flows are mostly in the part of the forecast further in the future, the calculation will incorrectly yield a payback period that is too soon. The following example illustrates this problem. We have an organization that has received a proposal from a manager asking to spend $1.5 million on equipment that will result in cash inflows in accordance with the following table. The total cash flow of the 5-year period are projected to be $2 million, which is an average of $400,000 per year. When divided into the $1.5 million original investment, this results in a payback period of 3.75 years. So, let's do a recap. We just said that the payback period is the time required for the amount invested in a project to be repaid by the net cash flow generated by the project. The main disadvantage of payback period is that it doesn't take into consideration the time value of money. In the next lecture, we'll go over the economic value added. See you there. Thanks for watching.